All right, this is section 8.3. We're going to do a similar process that we just did for proportions, but now we're going to apply it to means. So now we're going to apply it to estimating x bar, or estimating mu, instead of estimating p. Right, because the formulas for your sampling distributions are different when we're talking about proportions versus when we're talking about means. All right, so the way that changes the formula that we've had is that we have our estimate, which in this case is going to be our estimate mean, so x bar, plus or minus our critical value, right? We're still going to get that score off of our tables in the calculator, times standard deviation. But now the standard deviation is sigma over square root of n. Okay? That's going to be the difference in our formula. Now, there's going to be more that's going to be going on, but it just uses a different formula for that standard deviation. But there's one other big new thing in the formula that we'll talk about in just a minute. But I'm showing you this to see that it's the same structure of formula that the proportions were. You're going to take your estimate, the sample mean you got, and then plus or minus whatever the critical value was, times that standard deviation formula. Okay? So it would still be a very similar process. And this is using an example that we had in section 1 of the notes. Okay? So now we're going to do a similar example that we did before, but now with means, where we need to pick a sample size based on the margin of error we want. So for example, I'll give you a minute to read this example. Okay, they would like the estimate to be within 1 milligram per deciliter. So this is the margin of error that we want. So we want plus or minus 1. So we want 1 to be our margin of error, and then we know that this is our standard deviation. So we can plug standard deviation and margin of error into the formula. Since we want a 95% confidence level, we're going to use our 1.96 as our z-score. And so here is our equation, and we're going to solve this for n. So I'll give you a few seconds to pause and do that. So we get fraction on the bottom, square both sides, should get 96.04. Since we want a larger sample size, since we want the margin of error to be less than 1, we want a larger sample size to get a smaller margin of error, right? Because n's on the bottom. So 97 is the sample size we would need. Okay. Now, most of the time, our standard deviation formula relies on knowing the population standard deviation, right? Because it's sigma over square root of n. But most of the time, we don't know sigma. We don't know sigma. And so if we don't know that, and instead use the sample standard deviation, then it's a new table. It's a new table. So this is not a normal distribution anymore. So we can't use z-scores. So we're going to introduce a new type of distribution called a t distribution. So we're going to spend the next chunk of time talking about how to find t distributions. Okay? So this is when we don't know the population standard deviation. So most of the time we use formulas for means, we're going to need to use a t distribution. We're going to need to use a t distribution. still symmetric at 0, but it's got much more area in the tails. Right, so this is a t distribution versus our usual normal distribution. Okay, because there's more variability in sampling versus the population. So it's a different score. It's going to have a different table. You're going to find it in a different menu on our calculator. And there's one other thing that we need to know about t is that since the standard deviation of the sample depends on the sample size, each sample size has a different t-score. All right? And we call it a degrees of freedom. And it's degrees of freedom because it's basically how many people in the sample you can choose freely. And I'll talk about that in just a second. So degrees of freedom is the sample size minus 1, right? It's how many people you can choose freely. So if I'm taking a sample of 10 people, if I have a sample of 10 people, then I can, the order that I choose them in, I can choose 9 of them freely, and then my last person, I don't have a choice in who I choose because there's only one person left. So the degrees of freedom is the sample size minus 1. Sample size minus 1. And minus 1 is our formula for degrees of freedom. Okay? And usually we'll just get these scores out of a table or the calculator. Okay? And the larger the degrees of freedom, the closer we get to our normal curve. Okay? So degrees of freedom increase, the density curve approaches normality, which is what we said in chapter 7. Right? As my sample size gets larger and larger in the sampling distribution, we get closer and closer to a normal distribution. All right? So it's a new type of distribution, and we have a different table for it. So let's take a look at how we do that. So 95% confidence interval for the mean based on a simple random sample of size n equals 12. So what critical value should you use? Okay, so this is what your table looks like. This is what your table is going to look like. It's going to have a row. The rows are going to be degrees of freedom, and then the columns are going to be either probabilities or confidence levels, depending on what you're looking for. Okay? So first off, since we have 12 as our sample size, and minus 1 is our degrees of freedom, so we want 12 minus 1, or 11 degrees of freedom. And since we want our confidence level to be 95, then we want to look in the 95 column, and 2.201 is in the 11 row in the 95 column. Okay, so the desired critical value is 2.201. So let me just show you this very quickly. So this is the AP formula sheet. Okay, this is the AP formula sheet. First off, you'll notice that it's got that confidence interval formula. So if you're wondering how the formulas look on the AP test, this is how they look. Right? It gives you this critical value standard deviation, and then it gives you all the standard deviation formulas you'll need to know for the different types of intervals. So for sample mean, it gives sigma over square root of n. And this is what you're going to end up using. And you'll need to know, what you'll need to know is, okay, since I don't know the population standard deviation, I want to use t-score as my critical value in this formula. Right? That's what you're going to need to know. So it gives you the pieces to the formulas, and you're going to have to construct it yourself. You're going to have to construct it yourself. And then standardized test statistic, this is what we'll do in the next chapter. Okay, but let me scroll down to the table just so that you can see how this looks. Okay, there's your z-score table, and right after it, and same in the book, this is your t-score table. Okay, so this is the exact same table that they were showing. So we want the confidence level to be 95%. 95% confidence level. And here's 11 degrees of freedom on the 95%. Right? We'll talk about this top row next chapter. But right now we're doing confidence intervals, so we want confidence levels. All right, 2.201 for 11 degrees of freedom because sample size minus 1. And you can do this in the calculator as well. Same menu that you find your normal CDF and inverse norm, you're going to find a T-CDF and inverse T. So if you're more comfortable with the calculator, see if you can transfer over your knowledge about how we use the calculator for z-scores and see if you can get this 2.201 on the calculator for your t-scores. Remember, your degrees of freedom is 11. 12 minus 1. And you should get this 2.201. You should get about the same answer on the calculator. Okay. But back to our slides. Back to our notes. So this is what we're going to need to do within our formula to find our t-score that we want for the confidence interval. So we're going to have the value plus or minus our t-score times the standard deviation, which is just going to be the standard deviation over the square root of n. All right, so this time standard deviation over square root of n is our standard error. So here is our formula for confidence interval for means. And the reason we use a t-score is because we don't know the population standard deviation. So we can't use our usual formula for z-scores because it relies on the population standard deviation. So this is what we're going to use most of the time, almost all of the time. Unless you know sigma, unless it gives you sigma, the population standard deviation, which is not going to happen all that often. Might happen on the first couple homework problems, but after that, usually not going to happen. Then you're going to use this formula, and you want to use t-scores instead of z-scores. So let's look at an example here. Actually, first off, let's talk about conditions before we construct this interval, because we're going to use the same 4 steps that we've been using. Step 1, we're going to state what interval we're finding. Step 2, we're going to state the kind of test. So in this case, we want a 1 sample t interval. That's what this test is called. And step 2, we're going to give our conditions. And then step 3, we're going to do our calculations. Step 4, we're going to interpret the interval. And it's going to be the exact same interpretation as we did in the last section. So here are our 3 conditions: random, normal, and independent. Same 3 conditions, but they're ever so slightly different. Random, you still want to say that there was a random sample that was taken. Normal, this time, instead of n times p and n times 1 minus p, this time we're using that n is at least 30. Right? And that's because of our central limit theorem that we talked about in the last chapter. That if our sample size is large enough, then we're getting closer and closer to a normal, approximately normal distribution. So as long as our sample size is at least 30, then we'll be able to do this. And then our 10% condition stays the same. So you see how these confidence intervals kind of keep the same structure and format as to how we do the problem from the different types of intervals that we do. Okay. Then our step 3 is going to be plugging into this formula. Remember, degrees of freedom, n minus 1. All right, now we got an example. Okay. So it's on page 508 if you want to follow along. Okay, but it's asking the mean tension mu of all video terminals produced in this day at a 90% confidence level, right? Usually the population parameter is like stated in the problem, and we're just copying it onto here. Okay. And it should give us X bar as well, which we'll state in just a minute. Okay. So random, told that the data come from a random sample. Normal. Okay. So our sample size is 20 this time. So it doesn't meet our 30 threshold. But if the data still looks pretty close to a normal distribution, then we can assume approximate normality within our sampling distribution. Okay? So there are a couple different ways we can do that. We can enter the data and make like a box. So this is a box plot. This is a dot plot over here in A. B is a box plot. And C is a normal probability plot. And if you remember back in chapter 2, we said that a normal probability plot, we would want a linear pattern in a normal probability plot. That would tell us that the distribution is close to normal. Okay? And what we're looking for here in the box plot is for a symmetric distribution, right? We don't want a huge amount of skewness. We don't want a lot of curve to this. Okay? This is fairly linear. So we can assume normality here. And then independence, our 10% condition. So we're assuming that at least 200 video terminals were produced on that day. All right, here's where it's going to give us our sample mean and standard deviation. Okay, so on page 508, this is another way we can do it. Sometimes it'll give you data to put in a list and get the mean and standard deviation from there. And then sometimes it'll give you just the, it'll just give you the mean and standard deviation like it's doing here from the sample. So it just depends on what you're doing. Okay, now we can plug into our formula. So our formula needs a t-score. And the t-score for 90%, right, we want to use 19 as our degrees of freedom, n minus 1. So 20 minus 1 is 19. So we're going to do 1.328 as our degrees of freedom. And then on a 90% level with 19 degrees of freedom. Change that. At least if this is correct. 90%. Change that. We want to use the 1.328. Yeah, 1.328. So change this as well. But yeah, t-score, 90% level, 19 degrees of freedom. And then this is just our mean. And then here's our standard deviation over the square root of n, which is 20. So this is not quite correct. This is not quite correct. I'll put in the description of this video what the correct answer should be. I'll check it when I post it. Okay? And then step 4 is going to be your interpretation. And again, it should look pretty much the same as we did before. We are 90% confident that this interval captures the true mean tension in the entire batch. So, in other words, that we are 90% confident that the population mean, the actual population value that we want, the parameter, lies between these two values. 90% confident that the parameter lies between the two values. That's our outline for the interpretation. Or that these values capture the actual population parameter. So we're 90% confident that this interval captures the parameter. Right? This is just what the parameter, the mean that we're trying to estimate is. Okay. In your calculator, and we'll go over some calculator stuff tomorrow when we come back here. In your calculator, it's in your stat menu. All of these problems that we've been doing, you can plug nice and easy into your calculator instead of calculating out all the formulas. Okay? So in your stat menu, where you put in your lists and that kind of stuff and one variable stats, you're going to scroll over to tests. You're going to scroll over to tests, and you're going to see all the different confidence intervals and tests that we're going to be doing over the next few weeks. All right? And so we've done 2 of them so far. Okay? One of them is a t interval. Which is what we're doing right now. And then it's not z interval. This would be for means. We would want to scroll down and actually get 1 proportion z interval. 1 proportion z interval. We'll do tests next chapter. We'll use the tests ones next chapter. But 1 proportion z interval. So you should scroll down and you should find 1 proportion z interval. And you should be able to enter, when you go to it, it should give you either data or stats. Data means I entered the data in a list, into list 1, and I want you to find like the mean and standard deviation for me in the calculator. Stats is it gave you a mean and standard deviation and asked you to do the formula from there. So it's whether your data is if all the numbers are in a list. Stats is it just gave you the mean and standard deviation. Because if you put data, then it will run the list and calculate the mean and standard deviation for you in the calculation. And it should, if I remember correctly, it should give you the t-score that you're looking for as well. Okay, but we'll talk about that more, and we'll go through that together tomorrow, because we're going to do some free response questions tomorrow. Okay, and this one I will leave for you to try on your own. Think about your 4 steps that you would go through. In step 3 in your formulas, the answer you should get should be 9.6768 to 10.723. That's the answer you should get. If you're doing it correctly, and when I put it in the calculator, this is what I got out. So that's the answer you should get in the formula. And then you should be able to follow the rest of your steps from there. For degrees of freedom, if you're in the calculator, you want to use 249. And then in the table, obviously it doesn't go all the way up to 250. So you're going to need to look at the closest value, right? So in this case, it would probably be 100 would be the closest value in this table. If you're looking at the book, I think there's a 250 in the table in the book. I could be wrong on that, but I think there's a 250 in the table in the book. But it revolves around the same idea. This is what the calculator gave me as an answer. So you can try that on your own and see if you're doing your method properly. And if you got questions, we can go through some of that tomorrow in class. Right? So that's the biggest chunk of this. And so some kind of closing thoughts here. All right. So you'll notice that we still, in the first example, we still did the problem even though the sample size wasn't at least 30. And that's because usually we're okay as long as there isn't a strong skewness to the data. All right, so here's going to be our rule of thumb that we're going to do. Okay? If our sample size is less than 15, it needs to be very close to a normal distribution. If the data is skewed, don't say the normal condition isn't met, basically. We can't use the normal condition. So if the normal probability plot has a clear curve to it, if the data is too skewed, then we're not going to use that. And if there's a bunch of outliers. If the sample size is between 15 and 30, then we're good as long as we don't have a strong amount of skewness or very obvious and clear outliers, right? Strong skewness is what you would need between 15 and 30. And then if we're at least 30, then it does not matter what the distribution looks like. We can just say that the sample size is at least 30, so we can assume a normal distribution. Does not matter how skewed the sample size is. That's the central limit theorem that we talked about last chapter. So between 0 and 15, or between 1 and 15, between 1 and 15, we're going to say we want a symmetric distribution, not a clear skewness. We don't want outliers. Between 15 and 30, we can be a little more lenient and say we can take some skewness as long as it's not really strong skewness, and there aren't like some huge outliers. And then once my sample gets to 30, it does not matter what the distribution is. We can use a normal approximation and we can use t-scores. Okay, so that's when we're checking our normal condition based on these sample sizes. This is for checking the normal condition. All right, and this is your last homework assignment before the review. So tomorrow our plan is we're going to go through some free response questions. I'm going to hand out some free response questions on this section, and we'll talk about them. So that's our plan for tomorrow. We might also go through some things on the calculator just to clarify some of the things I've been saying. And then on Monday, well, tomorrow I'll also have the review for you so that you can look at it over the weekend. On Monday, it's going to be review day. It's going to be work day. And then Tuesday is going to be your test. So we're going to go through some problems together tomorrow to get you clearer on this topic. And then Monday is going to be your day to mostly to focus on like your work and your questions. Okay, so that's going to be our plan. And I will see you tomorrow.